Hi everyone. In this short video tutorial, I will show you how radar and its target simulator can be calibrated and verified using multi-channel signal view running on the 6 series MSO oscilloscope. Channel 1 of the AWG is connected to channel 1 of the scope and is used to simulate the radar transmitter's output. Channel 2 of the AWG is connected to channel 2 of the scope and is used to simulate monitoring and calibrating the echo target simulator's output. Let us launch the pulse table on both of the channels to analyze the radar and its echo simulator's output. The time overview display allows us to define the analysis time used for computing the pulse table. Let us enable the average on power, pulse width, and repetition interval measurements. The pulse width is 1 microsecond, and the PRI is roughly 50 microseconds for both radar and its echo simulator. The echo simulator ideally will not change the width or repetition interval. It applies delay, Doppler, and other clutter and channel effects before handing it back to the radar. Let us understand if it is applying any delay or not. To understand that behavior, let us turn on time measurements. There are 31 automated pulse parameter measurements that can be applied on each pulse for its channel and are listed in this table seen here. So the time measurements will give us the absolute time for the pulse starting position with respect to the trigger event. So in this case, it is 0, 50, 100 microseconds, and so on. Because we are applying the trigger on channel 1, it is the 0 position. It shows clearly that there is a 25 microsecond delay from channel 1 to channel 2. From the radar to the target simulator's output, there is a 25 microsecond delay. Let us analyze this delay in a more insightful way. We'll launch the pulse trace display to understand how Signal View is computing these numbers. Pulse trace gives us the exact pulse in which the measurement is being calculated in more detail. The pulse trace and pulse table are linked, meaning if you highlight any measurement in the pulse table, then the corresponding pulse will be zoomed and highlighted in the pulse trace display. For example, if I click on the pulse width for this particular pulse, it will zoom in on the pulse width measurement for the particular pulse. It provides a very quick way in understanding how the calculation is made and where it is made, and if we see any problems, this gives us a very quick way to observe the time domain signal. Here we're showing time and amplitude zoomed in. We can easily navigate from pulse to pulse to understand the behavior of the pulse train. Now let's create a moving target. The AWG is now configured to simulate a moving target. Let us understand the behavior using the pulse table. Like before, the pulse table for channel 1 looks the same. That is, time starts at 0 and increments by 50 microseconds for each pulse and so on. However, the pulse table for channel 2 is different. It comes in at 25, 75, and instead of 125 microseconds, it comes in at 129 for roughly a 5 microsecond delay. So this behavior can be easily seen from the pulse table itself. And visually, we can also launch the pulse statistics display to see the same behavior more visually. This display shows the time trend for any measurement. The pulse statistics display is launched on source 1, and the display is also linked to the pulse table. So selecting any pulse measurement on the table will reflect the same measurement in the pulse statistics display. Currently, the repetition interval is selected, so is reflected in pulse statistics display as well. And it is flat for channel 1, so let us change it to source 2. Let's select the RPI for source 2 as the target is moving, and so here we can easily see that it has a certain slope, and the slope is 5 microseconds. So this way we can visually see the characteristics of the radar target simulator from the radar. Similarly, there are 31 independent automated pulse parameter measurements per channel, which support the same pulse table, pulse trace, and pulse statistics display, as well as cumulative statistics, which adds the statistics results from one acquisition to the next. The results can be saved as a CSV file for further analysis offline. In summary, it can be really easy to calibrate and validate complex radar test systems with multi-channel signal view with all of these features.